Hi guys, today we're starting our unit on probability. What is probability? Well, it's how likely something is to happen. When we're talking about the probability of different events, there's certain words that we use to describe the probability. So if we were talking about snow in Ontario, if we were talking about whether or not it was going to snow in Ontario in January, we might describe that as likely. It is likely to snow in Ontario in January. However, if we were talking about June, we would say that it's unlikely to snow in Ontario in June. We'd like to say it's impossible, but it's not. In fact, only a few years ago, on June 4th in 2013, it did in fact snow in Ontario, in Northern Ontario and Timmins. So two of the words that we use to describe probability are likely and unlikely. Two other words we can use to describe probability are certain or impossible. So if we're looking at this jar of marbles, we could say that the probability of selecting either a red or a blue marble from this jar is certain. There are only red or blue marbles in there. So if you were to reach in and grab a marble, it is certain or 100% that one of those marbles is going to be either red or blue. On the opposite side though, if I asked you what the probability was of selecting a green marble from this jar, we would say that that is impossible. There's no possible way for you to select green because there are no green marbles in the jar. Another word that we use to describe the probability of something is called theoretical probability. The theoretical probability is what should happen in a probability experiment. So if you look at the coin that I've put down here below, a quarter, a Canadian quarter, we know we have two sides to any quarter. We have the head side and we have the tail side. So if we were to flip this coin 10 times, we would expect, because there were two options, that 5 times it would be heads and 5 times it would be tails. Theoretical probability is what we would expect to happen given the number of outcomes. So because we have two outcomes here, heads and tails, if we flipped it 10 times, half the time we'd expect it to be heads, half the times we'd expect it to be tails. Another example of theoretical probability would be if we were to look at something like the spinner we have below. Here we have 4 different options. We have blue, we have purple, we have green, and we have red. So we have 4 options or 4 outcomes. Outcomes is a word we use a lot when we're talking about probability. So there are 4 different outcomes. So if we were to spin this spinner 100 times, we would expect that that would be broken down into 4. So 25 times we would expect to get blue. 25 times we would expect to get purple. 25 times we would expect to get green, and 25 times we would expect to get red. So once again, the theoretical probability is what should happen in a probability experiment when you look at the outcomes, heads versus tails, against the trials, how many times you try it. So if you are using heads and tails and you try it 10 times would be your trials, outcomes would be heads or tails. The other way we can describe what happens in a probability experiment is by talking about the experimental results. So we just talked about the theoretical results, or the theoretical probability, and now we're talking about the experimental probability. So the experimental probability is what does happen in a probability experiment. So here what I'd like you to do is get one of the coins from the classroom, or if you have one of your own, and I would like you to flip the coin 10 times. Each time you flip it, I want you to record whether you got heads or tails. What did you find? Did you get 5 heads and 5 tails, or was it mixed? Something that's important to remember is that your theoretical and your experimental probability don't always match. In fact, they probably didn't when you did your heads and tails experiment, and that's okay. One of the things that we're going to learn about, though, is that when we increase the number of trials, so more trials, the more trials we do, the closer we get to our theoretical probability. So now what I would like you to do is take a minute, and well, it's probably going to take more than a minute. I want you to flip your coin 50 times this time and track it. When you flipped your coin 50 times, what did you find? Were you closer to 25 times heads and 25 times tails than you were when you did it only 10 times? Were you closer to 50%? Because if we were talking about the probability of flipping heads or tails in a percentage, we would say that we have a 50% shot of flipping heads and a 50% shot of flipping tails. At this point, each of you are going to create a note in your notebook using the page that's been provided to you with the vocabulary on it. The first thing that you're going to do is give yourself a title, probability vocabulary, like I've done here, and then I'd like you to cut out the 4 probability vocabulary words: likely, unlikely, impossible, and certain. And beside each, I want you to do your own example of an event that might be likely, unlikely, impossible, or certain. Okay? If it's hard to see here on our picture, the spinner, you can see here, it says based on this spinner, it's impossible to spin an odd number. That's because if you look at the options, they're 2, 4, 6, and 8. I know it's hard to see smaller, but you're welcome to do something like that if you wish, or draw marbles, or do a anecdotal event like I've done up here. But I would like you to have all of these in your book with an example of each next to them. The next thing that you're going to do is cut out all 4 of these puzzle pieces separately and match them up. So in the end, they should be partnered up. Theoretical probability should be partnered with what should happen in an experiment. And experimental probability should be partnered up with what does actually happen in an experiment. And then the last part of your note is going to be to glue this piece in and answer the question. How do the number of trials in a probability experiment affect the experimental probability? So if you remember when we talked about flipping heads and tails, the number of trials are how many times you've flipped them. So we expect, because of the number of outcomes, to get a 50-50 shot of heads and a 50-50 shot of tails. When you only did it 10 times, you probably weren't balanced 50-50. When you got closer to 50 times, you probably got closer. So how does the number of trials we do, whether we do it 5 times, 10 times, 400 times, affect how close our experimental probability is to our theoretical probability? Once you have that note complete, there is a page from your workbooks that you'll be given to do some practice with this stuff. Good work, guys.